The pros and cons of wind energy from turbines and large windmills. Air has mass, and when it moves, or when the wind blows, it contains the energy of that motion, kinetic energy. A portion of that energy can be converted into other forms, such as mechanical force or electricity. Then we can use it to perform work. Mechanical energy from wind is commonly used for pumping water in rural or remote places. The farm windmill is still a familiar sight in many rural areas. Mechanical energy converted from wind can also be used for other purposes, such as sawing logs, grinding grain, or propelling sailboats. By contrast, wind-powered electric turbines generate electricity for homes and businesses, and for sale to utilities. Approximately 0.25%, that's 1/4 of 1%, of the solar energy that reaches the lower atmosphere is transformed into wind. Although it is just a minuscule percentage, the absolute amount of energy is enormous. According to one estimate, North Dakota alone is theoretically capable of producing enough wind-generated power to meet more than 1/3 of U.S. electricity demand. Wind speed is a crucial element in determining whether a place is a suitable site for installing a wind energy facility. Generally, a minimum annual average wind speed of 13 miles per hour is necessary for a utility-scale wind power plant. In addition to being weather-dependent, intermittent, and unreliable, wind turbines cover vast areas of land and affect scenic views. They interrupt local wind flow, temperature, and moisture. They kill bats and birds of prey, with no penalties under migratory bird or endangered species law. They have relatively short lifespans and require massive amounts of raw materials compared to coal, gas, hydroelectric, or nuclear plants. Manufacture of turbine housings and blades involve enormous air and water pollution in faraway countries where a lot of the mining, processing, and manufacturing are done before turbine parts are shipped to America. The wind turbine blades are a toxic amalgam of unique composites made from petroleum products: fiberglass, epoxy, polyvinyl chloride foam, polyethylene terephthalate foam, and polyurethane coatings. A separate tractor-trailer is needed to haul each blade to the wind farm site, where huge concrete towers are constructed to anchor the turbines. In addition, significant concrete and asphalt is needed to upgrade rural roads to handle heavy turbine components. Manufacturing concrete is already the third largest emitter of carbon dioxide after burning coal, oil, and natural gas. It also requires nearly 1/10 of the world's industrial water use. At the end of their lifespan, when turbine blades need replacement, again, a separate tractor-trailer is needed to haul each blade away, this time to a landfill. Below you will find a link in the description of an article published by Principia Scientific entitled 50,000 tons of useless wind turbine blades dumped in the landfill. The amount of wind turbine blades slated for waste disposal is forecast to quadruple over the next 15 years, as a great deal more blades reach their 15 to 20-year lifespan. Furthermore, the size and length of the newly installed wind turbine blades are now twice as large as they were 20 to 30 years ago. Unfortunately, due to the way the blades are manufactured, it isn't economical or practical to recycle them, even though some small-scale recycling has been tried. Basically, there's just too much plastic composite epoxy that isn't worth recycling. We will soon have to permit entirely new landfills simply to handle wind turbine waste. And that's on top of mountains of used solar panels and dead battery waste. Yet advocates would have you believe that wind energy is cheap, clean, green, renewable, sustainable. Environmentalists and wind energy opportunists, entrepreneurs who take advantage of overly generous tax credits and multiple other subsidies, want you to believe wind energy is pure green. They never tell you about the costs or the environmental destruction that they have hidden from you for decades.